Hi guys, good morning. In this video, we're going to see the problem construct a binary tree from in-order and post-order traversal. Before starting, if you have been watching the video or after watching the video, if you like it, then please hit the like button. It helps make more videos. I don't know why, but yeah, let's see the problem. Construct binary tree from in-order post-order traversal. It is saying that we are given a binary. We are given two integer arrays called as in-order and a post-order, where in-order represents the in-order traversal of that binary tree. What the in-order traversal means, as the word itself says, in order, which means, see, in a tree, the root is the king, right? So every word is corresponding to the root. What root will do? In means root will come in between of everything. So basically, if I have a tree, root will come in between, which means that my tree will be formed something like left, root, and then right. Because for sure, left will come before right, right? So root is that, okay, I am in between. Post order means root is post. Post means after what? After everything, which means that left, right, and then root. Remember by that, because in a tree, root is the king. So everything, every name in a tree, like in reference to a tree, is for the root itself. So basically here the root is in between, here the root is post everything. And thus if you say in between, which means that one will come in between, left will come before it, right will come after it. One will come in the end, post everything. Two, for sure, like left will come before right. That is it. Let's see this problem, what we have to do. We are given this in order and this post order traversal, and we have to make something like this tree. And if we know that it's an in order traversal, so we know that, okay, if it's in order, then some part is left, then root, and then some part is right. If it's a post order, then some part is left, then some part is right, and some part is root. Cool. Let's see with the above example which we saw here. Let's see how we're gonna make our tree. So firstly, we have this in order post order array, but before starting we need to have something, right? See, if we want to start making a tree, how I will make a tree? From the end? No, right? From the starting itself. For starting, I need a root node. So first question in the mind is, can I get 3 anyhow? Let's see. So if I have this post order array and this in order array, I know that, okay, in order is left, root, and right. Root can be anywhere in between, but post order is left, right, and root. Root is for sure in the end, which means that I can find my 3 in the end of the post order. And yeah, that is true. So what I can easily see is, okay, I can get my root node from my post order because it is for sure in the end. So I got that root node in the end. Oh, I am super happy. I got my root node. But to move forward, I should be knowing about the left subtree and the right subtree. How to know that? Because here, if I go to see in my post order, I only know about the information of the root node. How I know what is the range of left subtree and what is the range of right subtree? How I know that? I don't. With this, to find, okay, what's the range of left subtree and what's the range of right subtree? What will help us? Our in order will help us. How? Let's see. If we know, okay, 3 is the root, for sure, if it's an element in the tree, so it's also present in what? In order, I will see, okay, it's present in order. Okay, it's present. Which means, in order means that, okay, it's left, root, and right. Which means that everything at the left of this in order is what? Is a left subtree, which means that 3, so this 9 and everything like before it is a left subtree. This 15 and everything after it is a right subtree of what? Of 3. So I can for sure know, okay, the information about the left and the right subtree is with the help of what? In order. I got this 9. Okay, I'm not sure it's the exact location of this 9, but yeah, the in order part will contain, the left part will contain something like 9 and the right part will contain something like 15, 20, and 7. I got the information by the help of my in order. And that's the thing. Okay, I got my root. I got, okay, what can be the left subtree? What can be the right subtree? Now let's move. let's move on to, okay, the next node I can find, because I have to make a tree. I have got this root node. Now I have to make another nodes, right? I know, okay, for sure the left subtree can look something like this. Like left subtree have nodes something like this. Right subtree have nodes something like this. But what's the location? We have to make a tree. So, and as we know that, okay, post order will help me figure out, okay, what's the root? So with that help, I previously know that, okay, my 9 was, this 9 was what? My left subtree, it was in my left subtree, and my 15, 20 and 7, it was in my right subtree, which means that I can infer, like I'm not writing it, I can infer that, okay, this 9, it will lie in my left subtree, and this 15, 7 and 20 will lie in my right subtree. Now as I move on, so I moved on to the next node. Let's say I moved on to this 20. So with this help, I can, okay, it is the root. But root of what? Because earlier 3 was root. But now it's a root of what? It's a root of my right subtree, which because see, earlier I knew, okay, right subtree had all these elements, 15, 20 and 3. But what is the root of that right subtree? That will help us with this. This 20 is the root of my right subtree. Okay, I got this 20, but it still had remaining those elements, which is 15 and 7. What's the information of 15 and 7? How, where are they, left or the right or the what? I just go on to Inorder. I'll ask him, oh, what's the left and right subtree? It says, okay, last time the range was 15, 20 and 7, which means the tree can only lie between this whole range, 15, 20 and 7. In this, my root is 20, which means that the remaining part is from 15 to 15, which means this is the remaining part, and the right part is this part. So for this 20, the left subtree is this 15, because see, the range has been fixed in the previous step. In the previous step I knew, okay, 15, 20 and 7 will form one subtree. In this subtree, 20 was the root. How I got to know? With the post order. But now I want to know, okay, what's the left subtree and the right subtree? With this, in this range only, 15, 20 and 7, I asked him, okay, what's the left of you 20? It said, okay, the left is 15. It's one element. It can be multiple elements. It's 15. It said, okay, it's 15. I asked him, what's the right of 20? It says, okay, it's 7. I say, okay, it's 7. Now I've got it. Okay, for 20 as a root, its subtree can have left as 15 and it can have many other elements, but right now it's just one element, which is 15, and right subtree can have elements 7. Cool. Then I just for sure know, okay, this particular subtree which had element 15, 7 and 20, its root node is 20. Now I moved on to the next node to find the next root. So I just landed onto the node 7. I'll say, okay, 7 was in the right subtree of 20. So for this 20, it is in the right subtree. And as I landed on it, so for 20's right subtree, it is the root node. Okay, it is a root node of the 20's right subtree. And with this help, I just went on to this 7. I asked him, hey, what's the left of you and what's the right of you? So that I can again make a left and the right subtree for this 7. But it says, okay, the limit is gone because it has just landed to one space, because earlier it was 15, 20 and 7. Then when 20 became the root, the limit became 15 and 7. When 7 became the root, limit is gone. So it is just here. So the left subtree and right subtree is null for him. Cool, no worries. I just move on to 15. Then now 15 will say, okay, and previously we know 15 was in the left subtree of 20, but now left subtree of 20 has a root which is 15. Okay, I will mark this 15 as the root of what? Of my left subtree of 20. Now what will happen is I just ask him, okay, do you have any left or right subtree? 15. Do you have any left or right subtree? It says, sorry brother, I don't have because my limit is gone. My left and right is gone. See, in white you can easily see it's the range of when 20 was the root. It's a range when 15 is the root. It's a range when 7 was the root. Right? So we are collapsing the range. Now, okay, cool. I'll just go on to next. So basically the post order thing is helping me find the root, and the in order thing is helping me find the range, what can be the possible for that root being that subtree, which means that a subtree is like this, a root. Okay, I found it. What can be the possible range of left and right subtree? I got this information with the help of Inorder. Cool. Then I moved on to my 9. I'll just ask him, as you can see, easily see, 9 is in white, which was in the first step when 3 was my root. I just marked, okay, 9 can come in the left subtree. So for 3, the left subtree will have 9. For 3, the left subtree will have 9. For that left subtree, the root is 9 for now. Okay, the root is 9. I just go and ask, okay, is there anything left on right of you? It can be, but for now it is not. So basically, for the 3, the left subtree's root is 9. Root I got 9. Now I just ask him, is there any left or right subtree for you? It was not. So for now, it is the root and is null. With this help, I can just make my entire tree. With the help of post order, I got to find the root. I knew what can be the left range and the right range. In the right range, I again find the root. I again know what's the left and the right corresponding range. Then again for this, I know what's the root, and I can just go on doing it. It's the same thing. I'll also try on an example. Firstly, I will explain the code and then I will try it on an example. So please make sure that, okay, you are staying and watching it. Firstly, I found my root index, because ultimately, right, what we need to know is that we have to iterate from the back of this particular post order. So basically, I'll just find, okay, what's the root index? Root index is just the end of my post order vector. Then I have this unordered map. Why? See, what's my ultimate aim? My ultimate aim is to find the location of that, to find this. Let's say if my 20 was the root, so I need to find the location of that 20 in my in order, so that I can find, okay, what's the left range and the right range. Let's say if 3 had been the root, so I just go and find 3 in my in order. I go and find 3. To find that 3 in order, I can do it in O of 1 by using an unordered map. And with this, I can, okay, no, if this is the pivot, then my left range will be from left to pivot -1, and my right range will be pivot +1 to right. It's pretty simple. With this help, I can get to know. With this help, see, by unordered map, I can get to know what is the pivot. But with the help of pivot, I can get to know what is the left range and the right range. Cool. I just got to know, okay, what's the unordered map, and then I just called a helper function which will actually help me find out the root. Now let's go out to the helper function. Firstly, any recursion have one base case, another is prime condition, next is recursive condition. First base case is, if we have, see, initially we had this pointer, let's take this one. Initially we had this pointer left to right. Cool. It is left to right. So at every point, I'm just collapsing this range of left to right, left to right, left to right. What if this left go beyond right? It's not a range, right? Left is here, right is here. It's a range. Okay, I can understand it. Left is here, right is here. It's also a range. One element. It's a range. Cool. But what is this? Left is more than right. That doesn't make sense, right? Because it's just like went beyond. So like it's no range at all. So if my left and right pointer by anyhow, because I'm just moving my left and right pointer, right, at every step, I'm just doing a left pivot -1 and pivot +1 to right. So if any point it just moves, so I just return a null. It's a base condition. Cool. Now the prime condition. Prime condition means making the root. So how to make the root? With the help of the pivot. Because see, I was at this root index. Initially I was at this root index. I knew, okay, it is the root index. Then what will happen is, it will just go and find, okay, what is the location in order for it, just so that I can find the, okay, what's a pivot like. With this pivot, I can find, okay, what's the left range and the right range like. And ultimately, as I have found my root, because see, it is a root index, right now. So it is the root element. My root index is 6, let's say. This element is 0, 1, 2, 3, 4, 5. And my root index is 5. My root element is 3. Then I have found my root element. I'll just make a node out of that root element, which means I'll make a node of 3. See, I just made a node of this root element, which is the post order of root index. I just made a node so that, okay, now I have a root node. With this help, I found the pivot in my inorder. I took the element of post order, moved it in the map of my, which I have made, to find, okay, the location of that element, which is the root element, in my inorder. I get this index called as pivot, and then I just reduce my root index, because in the next iteration I need what? I need my next root. Cool. It is the prime condition. Now comes the for sure recursive condition. Here, as you can easily see, that when we iterate from right to left, it is the root. Then what comes is the right part. So the root will be, the next root will be what? The next root will be the right subtree. So what I will do is that I just firstly mark my nodes right. Understand? Nodes right. Why? Because after using this root, the next element will be what? If the range is there, if the root has that right subtree, so it will be the root of the right subtree. So I just did a root index, and the new ranges, if I have this pivot, then the new ranges in order, the new ranges from my pivot plus 1 to the right, which means the end, in order. And you will ask, okay, Aryan, what if the condition would have been something like, okay, if you're standing at this element and you will just move on to this element, then what's the range like? The right subtree is not there, right? For this, the right subtree is not there. Okay, cool. It's a left subtree. So what will happen in the right subtree is the limits will overlap. So it will just return a null. That is it. So now what will happen is that in the, like, firstly we made this node root right, then we made a node nodes left, in which I'll just mark my left and my right as pivot -1, because the range have shrinked. Let's see this example quickly with the dry run of this. So firstly, initially, I have this vector, I have to make this tree, I have this inorder, I have this post order. For your convenience, you can just slow it down. Rest of the video you can see in fast. So firstly, what I will do is, in the actual main function, I'll just have this root index, which is the last index. As you can easily see, root index is 6. Then I have this unordered map, which will actually make the map of every element of this with their indexes. Cool, I got this unordered map, and then I'll just call this function. Inorder postorder map are just the vectors and the maps. Root index is the last index, which we found out here. 0 is the see, this index range is for the inorder, to find out, okay, what's the left and the right subtree range. It is the left subtree range, it is the left index, it is the right index. Okay, initially the limit is 0 to 6. Now what will happen in the next step is, I'll just call this function. It's the same function which is being called. Then ultimately, as it go on, it checks the base condition. Okay, is my left, which is 0, is it more than 6? Okay, no, so it will not return a null. Okay, it just goes on. Firstly, it will find the pivot. How it will find the pivot? It will just find the pivot. See, I have this element, I had this root index, I had the root index 6. With this index, I found, okay, what is the post order of 6? It will give me a 1. With this one, I find, okay, I have this one. Now I need to find the index, which is this 3. So with the pivot, I found the unordered map of 1. One is just a post order of root index, and this gives me a 3. Cool, no worries. Now I made the tree root node, and I just reduced my index so that I can just, next time I can just have it at this 5. Cool, no worries. Now comes the interesting part of making my right subtree and left subtree. So as you can easily see, I just write both of these conditions down right here, that okay, it will become my new root index will become 5, this one. My left range for what? For my right would become pivot plus 1, which is, see, it was the root, right? So it was the pivot. So my new right range will be this is pivot plus 1, and it was right, and my left range will be pivot minus 1, and it will be from left to pivot minus 1, and the right range will be pivot plus 1 to end. It is the same thing. It is pivot plus 1 to right and 0, which is the left, to pivot minus 1. And then again I'll just call both of these to get the left and the right subtree, but as the right subtree recursive call is above, so it will be called first, and when the right subtree call is completed, after that only my left subtree call will start. How it will go? As it is being called 5, 4 and 6, it is being called. Ultimately again it will just the same thing. It will just see, okay, if 4 is more than 6, no it is not, then it will find, okay, what's the pivot index. So as you can easily see, my 3, its pivot index is this, so this is now my new pivot. This is now my new pivot, and you will also see that, okay, my new left and right are, my this is left, my this is right. So my new left and right were this, left and right. Cool. Now again what will happen is that it will just make this root element, root element is made, root index is reduced. Now next root will be something like this for the next iteration, not for now. Now comes the main part of recursive calls. You can see the recursive call is, now the new root index is 4, as you can see, 4, new root index. New left range for the right subtree, see, it is the right subtree part, so it is the left range. As you can easily see, it is the pivot, so the new left for the right subtree. Now I am speaking about the right subtree, right? What it will be from pivot plus 1 up till the right, which is this, which is from 5 plus 1 up till 6, which was the right range. See, here is the 6, it comes from here. Now for the left subtree, which is from the nodes left, root index will remain same. What will be the left range? It will be from left to my pivot minus 1. Pivot was 5, minus 1 will be 4, so left was actually 4, so it will be from 4 to 4. You can easily see it left was for sure 4, as you can see, left was 4, and now it will be 5 minus 1, which is 4, and same will go on further for every part. When the right subtree is finished, which means when the right recursive call is finished, after that it will just start on the right left calls, and it will be exactly same as that of these calls which we showed above. The complexity is O of n, as we are iterating on every post order node. Very simple as that, and space is also O of n, because we are using an unordered map to actually store that element. I hope that you guys enjoyed the whole intuition. Firstly, I explained with an intuition, then I showed the code, then I also dry run that code, because recursion is very complex for you guys. So I hope that I should dry run that. So like a bit length has gone for this video, but yeah, I think it was worth it. So if you guys like the video, then please hit the like button. It helps motivate a lot, and see you in the next video. Goodbye, take care. Bye, I'm rapping, yaar. Cool. Bye.